Right, so in this video I just wanted to go through the solutions to the second lot of pH indicator questions that I gave you for the weekend. So the first question was Arnis's definition of a base. Well, you're just going to say that a base dissociates in water to produce OH minus ions, okay? And why is NH3 considered to be a base according to the Bronsted-Lowry theory? You're just going to say that NH3 accepts protons. So be careful now, they asked you for the Bronsted-Lowry theory there in part 2. So you just say that NH3 accepts protons and therefore it behaves as a base according to Bronsted and Lowry. Now, the calculations now next, they ask you to calculate the pH value of a 0.5 molar solution of HCl, okay? Now, you know that HCl is a strong acid. Also, there has been no mention of a Ka value, so you know that that's another indication that it's a strong acid. Now, strong acids fully dissociate, so you're going to say that, if I have HCl here, H plus and Cl minus, and so if you've got a 0.5 molar HCl, then you're going to have, I had that written there already, then you're going to have 0.5 moles of H plus ions, and then all you do is you fill that into your pH formula, 0.5 molar, and you get a 0.3 pH value for that. Now, that's if it's a strong acid, okay? A weak acid then, in the second part, they told you the same concentration, but it's ethanoic acid. Now, we know that ethanoic acid is a weak acid because it's an organic acid, but also they give you a Ka value, okay? So that's how you definitely know this acid is a weak acid. Now, what was our equation for calculating the pH of weak acids? Ka times Ma, wasn't it? So you have hydrogen ion concentration to be squared equals Ka times Ma. Now I'm going to manipulate the formula there straight away by getting the square root of both sides to get rid of the squared, and then the hydrogen ion concentration is going to be the square root of your Ka value up here, look, is 1.8 by 10 to the minus 5. That was given to you. You know the concentration of the acid is a 0.5 molar acid. So when you do all of that, you get a hydrogen ion concentration of 3 by 10 to the minus 3, okay? And then what are you left to do? You're left to fill that into your pH formula, and you're going to get a pH value of 2.52 for the ethanoic acid, okay? Now, second part of that question then shows you a pH curve. So you should have that pH curve there now in front of you, okay? So it shows you a pH curve, and it says that this curve was obtained when 100 cubic centimeters of 0.5 molar sodium hydroxide was gradually added to 50 cubic centimeters of one of the above acids. So the above acids you have to choose from. You have ethanoic acid or HCl. So you must look at the curve now. So look at the curve, okay? Which of those two acids solutions would have been neutralized, okay? Now, I have a photo here. I'm just trying to, if it's that exact question there. So if we look at this photo, okay, or this graph, how would I know which acid was used here with titration with sodium hydroxide? Well, first of all, look at where it's starting. Look at your axis. That's a pH value of 2 it's less than 2, it's less than 3, so 3 would be roughly there, so it's about 2.52. Now, which of our acids had a pH value of 2.52 when you calculated it, okay? Our HCl had a pH value of 0.3, that would be way down here. So if it was HCl, your graph would be starting down there. So it's ethanoic acid, because it asked you then to give two pieces of evidence from the curve. So you'd have to say that the curve starts at a pH value of roughly 2.52, okay, not 0.3, you could say that as well, not 0.3, clearly not 0.3. Now, what other bit of evidence from the curve tells us that ethanoic acid was involved? Well, where do you see the sudden rise? So it's gradually rising, You're seeing a sudden jump here between here and here. So roughly 7 and 11. I would always have learned 7 to 10. And the textbook says 7 to 10. But in a lot of exam questions, you see the rise going as far as 11. But anyway, 7 to 10 would be perfect. So there you go. So you'll see the sudden jump. If it was a strong acid like HCl, you would have seen a sudden rise at 3. So the rise would have started here, between 3 and 10, the sudden jump or the sudden in pH. So that's the second bit of evidence there. Now, the last part of that question then was, what is the essential property of an indicator used to detect the in point? Well, You want an indicator whose range lies within the sudden jump in pH, okay? Or if you say that it has to be one colour, it has to change colour, I suppose, within the sudden jump. So if we look at phenolphthalein there, 7 and 10, what colour is phenolphthalein at 7? Well, it's colourless. What colour is phenolphthalein at 10? It's pink, because the range of the indicator is 8 to 10. So anything below 8, phenolphthalein is colourless, and anything above 10, phenolphthalein is pink. I know I've gone through this before, but just to reiterate again, if it was methyl orange, the range of methyl orange is 3 to 5. So below 3, it's yellow, and anything above 5, it's pink. What colour would methyl orange be at 7? At 7, it would be red, actually, wasn't it? Sorry, red was the thing we were using. And at 10, it would also be red. So would methyl orange be suitable as an indicator? No, because it's red at 7 and it's red at 10. No. You need an indicator that changes colour within the sudden jump in pH if you want to be able to identify that sudden jump. And that's where neutralisation occurs. So we want to be able to identify that. Okay? Now, question 2 then, you had defining a base according to Bronson and Lowry. Well, a base is a proton acceptor, and a conjugate acid-base pair is any pair that consists of an acid and a base and differ by a proton. And then they asked you for the conjugate acid of H2O. Now, if you're looking for the conjugate acid, this must be behaving as a base. Then you say to yourself, how do bases behave? Well, bases accept protons, so add a proton onto that. Now, if you're unsure about the charge, double check the charge. There's no charge on the water currently, so that's 0 plus a +1. 0 plus 1 is +1. So that's where I got the +1 there in the H3O. Okay, part B then asks you to define pH. Well, you know the definition of pH, so all you'd have to do there is write down your formula as such. Put into the base 10. It hasn't been in bold in the marking schemes, but I think it might be no harm to put in just in case. Now, I thought this question was very poorly worded, I suppose. It's kind of hard to figure out what's going on. So if I was you reading it, I'd try to make it a bit more straightforward for myself. So I would be saying the pH values of 0.1 molar solutions of, and you've 3 acids. So I would be saying that 0.1 molar H2SO4 has a pH value of 0.7, okay? I'd be saying that a 0.1 molar HCl has a pH value of 1. And then I'd say to myself, 0.1 molar ethanoic acid. Sorry, it is methanoic acid. Sorry, I thought it was ethanoic acid. Okay, so 0.1 molar methanoic acid, that's a H there, has, what is the value for that? 2.3. So do you see that makes it, I don't know, does that make it a bit clearer? So try to make the information in the sentence as clear as you can. Now lads, remember, the more look at your formula, look for pH. The more H pluses that you're putting into that, then the more acidic your solution is going to be. And remember the pH scale, the lower the value, the more acidic. So the closer to 0, if you like. So the lower the value of pH, the more acidic your solution is. The more hydrogen ions, the more acidic our solution is going to be, okay? Now, in the first part of that, they asked you to describe, in terms of hydrogen ions, the difference between the pH values of the hydrochloric acid and the sulfuric acid. So this is the pH value of the sulfuric acid, and this is the pH value of the hydrochloric acid. How could you explain, in terms of hydrogen ions, why the pH, these are all pH values, remember, why is the pH value of sulfuric acid 0.7 and the pH value of HCl is 0.1? Okay, now the reason being, of course, they're both strong acids, you see. I think that would be an important point maybe to make in your answer. So you're going to say that, yeah, okay, both of these acids are strong acids. However, sulfuric acid is a dibasic acid. So for every molecule of sulfuric acid, you're going to get 2 H plus ions, whereas HCl is a monobasic acid. So if you plug in your value there of 0.1 molar, then here you're going to get 0.2 molar H plus. Here you're going to just stick with the 0.1 molar. Because you have more H plus ions, then you are going to have a lower pH value. More H plus ions means the solution is more acidic, so you're going to have a lower pH value to represent that. Okay, so the big thing there, of course, Now, it might be no harm to put in the dissociation. I think it'd be no harm to put in that 0.1 molar sulfuric makes 0.2 molar H plus ions, or that kind of thing. But your point, of course, is that yes, they're both strong acids, but the sulfuric is a dibasic, whereas the HCl is monobasic. Now, you're also asked to explain, in terms of hydrogen ions again, why the HCl has a greater. If the HCl had a pH value of 1, whereas the methanoic acid, the weak acid, had a pH value of 2.37. Now, of course, your answer there is that it's a weak acid. And the fact that methanoic acid is a weak acid, it means it does not fully dissociate. So you're not going to get as many H plus ions using a weak acid as you would get it with a strong acid. So you're saying that it's a weak acid, doesn't fully dissociate, there aren't as many H plus ions. Okay? Now, you're asked to calculate something then. So it says use the pH values given. Sorry, no, just get rid of that for a second. So use the pH value given for the 0.1. Now, what was the pH value for a 0.1 molar methanoic acid? It was 2.37. Lads, the minute, I was trying to make this point to you in the last videos, the minute you see a pH value, you are immediately thinking, I can calculate hydrogen ions, because pH is minus the log of the hydrogen ion concentration. So my hydrogen ions will be the anti-log of minus the pH value. Do not forget the minus there. So, excuse me. So when you plug that into your calculator, then you are getting a hydrogen ion concentration of 4.27 by 10 to the minus 3. Okay. So the minute you see the pH, calculate the hydrogen ion concentrations. And then in the question there for part 3, you're asked to calculate the Ka value. Now, your formula for calculation of weak acids was the hydrogen ion concentration to be squared. When you're looking for the Ka value, keep the squared. It makes it more straightforward if you keep the squared, okay? So then you have hydrogen ion concentration to be squared. You don't know the Ka value, that's what you're asked to calculate. And you do know the Ma of the acid, it's a 0.1 molar. Look, you're given that at the very beginning. And then when you manipulate that, so what was our hydrogen ion concentration again? Here, look, so that was 4.27 by 10 to the minus 3 to be squared is equal to the Ka times 0.1. And then if you divide both sides by 0.1, you get a Ka value of, where's my Ka value? Oh, here it is, 1.82 by 10 to the minus 4. Okay, so that's my Ka value. All right, so keep the squared this time. Don't get the square root. Keep the squared because it makes the calculation a bit more straightforward. Okay, then in the second bit of that calculation part there, you're asked to find the pH of, now lads, will you be careful? It's a different concentration, methanoic acid. Now the fact that it's the same acid means that the Ka value is the same as what you just calculated in the previous part, okay? So now how will you calculate the pH? Well, hydrogen ion concentration to be squared is equal to Ka times Ma. Okay, this time do square root both sides because it makes the calculation a little bit easier. And then you're going to fill in your Ka that you calculated, the Ma that you were given. Be careful now to use the right molarity there. And the hydrogen ion concentration, when you do that, works out to be 3 by 10 to the minus 3. And then, of course, you have to plug that into your pH formula to get 2.52 as the concentration of the methanoic acid. Okay, is that all right?